In this chapter, now I'm going to show you a demo application. But before I get into demo, I want to explain you how to build simple applications using large language models. Again, even if you're not a technical person, please stay with me. You will understand how easy it is to code these generative AI applications. Once you see this, then it becomes very easy. So let's get started on this. How to use LLMs, or how to use LLMs from OpenAI or DeepSeek or Meta. You can use, there are many of them nowadays, or Google. But important is that you learn how to code these applications, how to build these simple applications. So how do you use LLMs? First step that you need to do, and I'm just showing you a sequence. For you to use LLMs, first you need to decide which LLM you are going to use. You need to probably spend time to just learn about, OpenAI or Hugging Face transform models that you want to use. You can download these models, run those locally, but I'm going to make it easy on you to understand how to do it. Once you decide on the model, then you decide which task that you are going to code this application for. Are you going to code for performing question answers, like you're building a chatbot that can answer question for you, or are you building an application for language translation, or are you building for summarization or sentiment analysis? Whatever task you want to build application for, that you decide that what that task is. Then you prepare your input, how you are going to provide the input to that to the LLM. Then you configure your models with different. There are kind of configuration settings like temperature or maximum tokens. There are different characteristics that you can set parameters for. So you can configure that. Then it will generate output for you, right? You take that output, you post process that output, you clean the formatted models output for usability, and during all this you need to consider ethical considerations. So again, that's a very simple process. We don't need to discuss at length, but what I want to get your attention on, that transformers provide a very standard interface for you to perform different tasks. Now, if you see from the left, you can provide input to perform certain tasks through a OpenAI standard interface or LLM standard interface. And that standard interface will provide you different task heads. And task head, let's understand what is task head. Task head is a head that will perform a specific task for you, like sentiment analysis. So if you want to perform a sentiment analysis on your input that you have provided, then you call the task head called text classification. When you call this task head, it uses a pre-trained model that is trained to perform sentiment analysis or classification and provide you output. But let's say if you want to perform different tasks like named entity recognition. And named entity recognition is essentially identifying real world objects in the text that you provide. Real world objects like people, cars, places, books, stuff like this, something that is real world. So if you have a large text and you want to identify what are the real world objects in that text, then this task head called NER is what you want to use. It will use a pre-trained model that is pre-trained to do that, and it will provide you output. And I'll show you in this all this in demo. So it will become very easy for you to understand. Then, if let's say if you want to perform question answering, then you call task head called question answering. You provide the context and you provide question, and it will give you answer. There is a pre-trained model for it. That task head will use that pre-trained model. So you see, for every different task, you use different task head, and then that task head will use a pre-trained model that either you can tell it which model to use, and then that will use that model and get you the answer. So same thing for summarization, translation, text generation, vision, speech recognition. There are so many different tasks that it can provide, right? But each task needs a task head and a model for it. So now, before getting to demo, just to explain you the standard interface, and there's a function called pipeline. So let's say you provide input that the movie is fantastic. Let's say that's the your input, and you select a task head called sentiment analysis, and you provide that to standard interface of the LLM. What it does, it uses that. Now, since you have provided sentiment analysis as a task head, you also are looking at pre-trained model that is going to perform that. So what you need to learn is there is a function called pipeline that you need to call. Pipeline is a function that abstracts everything in the transformer. It simply allows you to provide the task head and the input, and it will do everything for you. So that's what pipeline makes it so easy for anybody to code the generative AI applications. It actually abstracts all these different things, these different layered APIs, and it actually simplifies how you can use that pipeline function and get the answer that you want. So all you need to do is instantiate that pipeline function, specify the name of the task, provide the input, and you'll get the answer. It's as simple as that. So let's get into the demo. By the way, the demo that I'm going to show you is at this GitHub pages place that is on my repo. So I have uploaded all this code at my repo in GitHub. I developed this code, and you can download that code from there, and you can play around that code however you like. If you don't want to play with the code, then you can just go to this location, and you can play with that application yourself. So let's get into the demo. Now, hopefully all of you can see the demo application that I'm showing. This is a simple application I built, and I'll walk you through the code as well so you understand. So you see what you see on screen. On the left side, there are these different tasks that you can provide, like sentiment analysis, named entity recognition, question answering, summarization, translation, or text generation. And there are more tasks that you can code for it. I just chose these ones so you understand. On the right side, there is an input text area where you can provide the input for the task to be performed, then the button to run the task. And then in this section, I will explain you the simple line of code for each of the tasks so you understand how easy it is to code. And this is the area where you will see the results of the task. So, and this is, by the way, I'm executing this against transformers at Hugging Face. Hugging Face has a large library of a lot of transformer models that you can use, and I'll show you how to use that in code as well. But let's start with the first task called sentiment analysis. So I've selected sentiment analysis. The input that I'm providing here is that I really enjoyed this movie. It was fantastic. And if I run this task, I want it to perform sentiment analysis and tell me the sentiment of this statement is positive or negative. If you look at the code, and I'm showing very one line of code. The most important line of code is this one. It's very simple. All I'm doing is calling that pipeline function. I'm providing the task head called sentiment analysis, and I'm providing this input from this input text area as input text, and I'm asking it that, hey, on this input text, please perform sentiment analysis and give me the result. And this is the result that I'm going to show you display here. It's as simple as that. So again, even if you're not a technology person, pay attention. It's very simple. All we need to do is call pipeline function, provide what task head that you will perform based on this task, and then insert the input from here, and then store that output that LLM will provide to you in the variable called result, and display that variable here in this area. That's all I'm doing. So let's execute. So when I run this task, now you see pretty quickly they came back with the result that a sentiment for this statement is positive, and the confidence level of LLM that is very high. It's saying that I'm 99.99% certain that sentiment on the statement is positive. Now let's say if I change it, I today is that day. And now I expect it to perform sentiment analysis and come back with a answer negative, right? Because today is a bad day, should have negative sentiment. So let's perform that. Here, now if I execute that, see, immediately came back with sentiment as negative, and this time is still high confidence level that on the statement sentiment is negative. So that's about sentiment analysis. Very, very simple to code the generative AI applications. Um, Next is task I'm choosing is name entity recognition. Named entity recognition, I'm going to provide input called WEX CEO Melissa Smith visited Dallas last week. That's what I'm writing here. And the code for that now is again fairly simple. I'm calling pipeline function, but this time I changed the task head from sentiment analysis to token classification. I'm saying use task head now token classification instead of sentiment analysis. And again, take the input from this text area called input text, give you the result, and I'll show you the results here. So this time when I execute that task, it came back with the named entity recognition. It somehow the model probably is not that good. It messed up the first word, Rex. It split into two words, but it got the next words right. It determined that out of this all this, Melissa seems real world person, and it's saying here that it's a person, and it's trying to tell me the index. It actually gave me the wrong index because it messed the first two words. But you get the point. It's actually determining the real people, and it's telling me that this is person. But for Dallas, it found out that it's the real world object, but it's saying that it's a location. So you get the point, right? It actually performs named entity recognition task on it and gives me the result. Now, let's perform third task called question answering. And this is an important one when you're designing a chatbot to ask questions and get answers from it. So in this case, I'm providing input that the Eiffel Tower was completed in 1889. And on this context, I'm asking it a question: when was the Eiffel Tower completed? Um, and if you look at the code for it, I'm again using pipeline function. This time my task head is called question answering. And then I change the task head. And I'm also passing now two new parameters. One is called question, and question is this question that I'm asking. And before that, I'd used parameter called context, which is before question. So I'm saying that anything before word question is the context that you should use to answer the question that I'm asking after the word question. That's how it's coded right now. So if I execute this task, it quickly came back and answer for the question, when was the Eiffel Tower completed? 1889. And the confidence level is fairly high. Now let's say if I change this context to say that WEX is located, WEX headquarters or WEX office is located at Portland. That's the context I gave. And if I ask question, where is WEX office located? If I do that, then I expect it to give me answer Portland. Let's see if it does that. Sure enough, right? I asked question, where is the WEX office located? It came back with answer Portland because it took this context, and on this context it provided me the answer. So it can provide answer on context, or it can provide answer on all the information in the internet, because it has actually created that map of the world for the internet data as well. So that's about question answering. Now, summarization is I can give this large text to it, and I'm giving it a text about United States of America, founded in 1776, the Federal Republic composed of 50 states. I'm not going to read the whole thing, but you get the point that I'm providing it a large text. And now I'm changing the code and again calling the pipeline function. and I'm changing the task head to summarization this time. I'm also giving it an input text here. Now, there's one more parameter that I added here called max length equals 100. What I'm telling here, that summarize this, but keep it less than 100 words. That's what I'm telling it. So, let's run that task. This one particularly takes a little bit more time. Probably that model is not very efficient from Hugging Face. So now here it came back with an answer, which is not answer, the summary of this large text. So it summarized this text and it's summarized in less than 100 words. That's what the summarization task does. Now, next one is called translation. And I'm going to use simple word, hello, how are you? And I'm going to now, the code is again calling pipeline function. This time task head is translation. I'm providing input text, but there are two more parameters I'm passing on now. One is called source language. I'm telling the model that source language is English and target language is Hindi, because that model is capable of translating from any language to any language. So it needs two more parameters for it to know, hey, what is source language and what is target language. So I'm telling it that translate this from English to Hindi. So let's try that. Once I execute that, it should come back with an answer. This one also takes a little bit time. It came back with an answer, Namaste aap kaise hain, which is literally the translation for hello, how are you? So if I change this, I love pizza, then let's see what it comes back with. This model does take time. Well, it came back saying that mujhe pizza pasand hai, which is literally a translation for I love pizza. And then finally, the last task is text generation. Here, I'm providing the input my favorite food is. I'm calling a pipeline function. The task head now is called text generation. I'm also providing the input text, and I'm trying to tell in that max length, limit the answer to less than 50 words. Don't do more than 50 words. So then I execute this. It will actually try to complete that sentence, and it did. It said that my favorite food is chicken breast. In reality, it's not. It doesn't know my favorite food, so it just came up with some random answer based on its map of the words. Um, but I there are a lot of other fruit types that I like more than chicken breast. But um, this I hope it gives you good context. Now let me stop sharing this and let me show you the core of this application. So hopefully now you see my Visual Studio where I'm just showing you the simple code. There are only three simple files. One is the index.html, which is essentially the user interface for that demo application that you just saw. And I provided comments everywhere so you can understand. The CSS file is just essentially a styling for that. The main logic is in this JavaScript file. So this is a generative AI or JavaScript file. JavaScript file this is the file where there's a lot of logic. Again, you can write this in any language you like. You can write this in C Sharp, Python, Java, whatever language you are comfortable with. I wrote this in JavaScript because I like JavaScript. I'm good at it. But it's up to you. The OpenAI pipeline that I talked about is pretty flexible. If you look at this line of code, this is where I'm importing the pipeline from this Hugging Face URL. I'm using the transformer library from Hugging Face. Hugging Face is a very rich place that hosts a lot of transformer libraries around the world. You can read a lot there as well. But just to tell you that that's where I'm importing my pipeline from. In this line of code, I'm actually ensuring that local models are not used. And then in this section, I'm configuring the task configurations. So for sentiment analysis, these are the things that I'm using, but especially for model, I'm using this model for sentiment analysis from Hugging Face. From for name entity recognition, I'm using this model from Hugging Face. For question answering, I'm using another model. So you can you can configure the models that you want to use. You can try out these different models. So what I would recommend all of you is that get hold of this code from my repo. Let me show you where my repo is. So this is where my repo is. I've shared that um, URL for the repo, and you can with this simple application. You can just go with this code. You can download this as a zip file and store it on your local. If you want to use it locally, you can actually deploy some simple web server and run it from your terminal. I'm also running one from my local, and I can execute that from my local machine as well. But but if you actually deploy this on GitHub, if you create your own repo, then you can also host from GitHub pages, and then there are a lot of different instructions that you can use. But if you on your repo, if you go in settings, then there is these pages. Once you create your repo, then you can go in pages, and actually you can deploy that from your main branch, and then you will have a public um, hosted URL like this, um, and then you can execute it from there. I would recommend you to change the code, try out different models, and give it a shot.